All right, we have gone through a lot of different types of factoring. Now, for the first type of factoring we did, A had to be 1. And for the second one, we used GCF when A was not 1, when A was greater than 1. So what if A is greater than 1 and we can't remove a GCF? So let me give you an example of that instance. We have 6x squared plus 19x plus 15, and we want to factor this. Well, as I mentioned, A is greater than 1. A here is 6. B is 19. And C is 15. Let's look at the factors just to make sure that there are no common ones. So I'm going to take out my factor sheet. 6 has 1 and 6, 2 and 3. So 1 and 6, 2 and 3. 19 has 1 and 9. I'm sorry, 1 and 19. 15 has 1 and 15. 3 and 5. Now, probably the big red flag here is this 19 only has 1 and 19. Sure, they all have 1 in common, but removing 1 doesn't change them, right? If I remove 1, I'm left with 6. If I remove 1, I'm left with 19. If I remove 1, I'm left with 15. It didn't change them at all. So we actually can't remove a greatest common factor. So we're going to use what is known as the swing method. I'm going to go ahead and erase all this here. To do the swing method, we are going to take this A, which is 6, and we're going to swing it over to the 15. And by swing it over, I mean we're going to multiply it. So I'm going to go ahead and rewrite this now as x squared plus 19x plus 15 times 6. Okay, so let's go ahead and calculate 15 times 6. Which we can go ahead, I could take out a calculator, I could do 15 times 6, that's 90. Okay. This is only temporary, right? Like if you've ever been on a swing, you know when you go forward, you're not stuck forward, right? You're eventually going to swing backwards, right? So here's us swinging forward. We're going to swing this 6 to multiply to the 15 here. And that'll give us 90. Here, this is just a polynomial that can be factored. So this is factorable. And this is going to be factored using math, right? We want to multiply to our C value, which is now 90. It changed. It was 15, but don't worry, we'll adjust. And we want to add to 19. So I'm going to go ahead and look at the factors of 90. Bottom of my list here. So I got 1 and 90. That adds to 91. 2 and 45. That adds to 47. 3 and 30. That adds to 33. 5 and 18. That adds to 23. 6 and 15. Hey, we multiplied those. Okay. Those add to 21. 9 and 10. Okay, these add to 19. So our factors are 9 and 10. So if I write my factors, it's positive 9, so I write x plus 9. Positive 10, so I write x plus 10. So we swung forward, right? We now have to swing back. And what we're going to do is instead of multiplying, right, how we multiplied here, we have to swing backwards. So the opposite of multiplication is division. So I'm actually going to divide both of these things, both of our factors, let me write this in red, by 6. Right? If you swing forward, you have to undo it, you have to swing back. So this is something that we have to put into Desmos. I'm going to do 9 divided by 6, and I'm going to convert that to a fraction. Do 10 divided by 6, I'm going to convert that to a fraction. So 3 over 2, 5 over 3. This is going to be x plus 3 over 2, x plus 5 over 3. And the final part of swinging back is we actually have to take the denominators and put them in front of the x. So this will be 2x plus 3 times 3x plus 5.